All right, hello and welcome to day 3 of Unit 2. So we're talking about transformations. And so what you should have for your do now is right here on the board. Sorry, this is not erasing. And I'm just erasing these little tick marks because I accidentally put them on there. So this is your do now. If you have any questions, this drawing over here, this is a reflection across the x-axis. And then down here I've done a rotation counterclockwise. So counterclockwise again is going to be going this direction to the left. And so you change the y coordinate and keep x the same. But they flip-flop positions because remember you wear flip-flops in 90-degree weather. All right, if you have any questions, let me know. Let's move on. So now you're going to pause the video and you're going to go ahead and complete these 3, reviewing the rules we have already learned, and then we'll go ahead and learn something new. So pause it, work them out, see if you got them right. If not, you need to review. So this is what you should have for each of these situations. First of all, a reflection. If you were to write this in symbolic notation, the rule, what you would do is you put a little r, and then you would write y-axis down here. And then you know that the rule is the x changes and the y stays the same. Okay, I've done the same thing for rotation, but since rotation and reflection both start with the same letter, if you're going to write symbolic notation for rotating 180 degrees, notice you use a capital R, and then you just put a little 180 degrees down there. And the rule is that both the x and the y change. So these are your coordinates, and this is the picture. And then the third one is rotate counterclockwise 90 degrees. And what you should notice is that it's going to go from here, from first quadrant, back 1 quadrant. And so your new points are at -4, 4, -1, 2, and -3, 0. So it should look something like this. Okay? And if you're struggling with these, it's just a matter of studying. Because today we're going to learn a new rule. And this one's called a translation. And so a translation is a transformation in which every point in the figure slides. So if you think back to our picture of the cats, you'll notice that the cats here are sliding up. And when we're writing a rule for a translation, we use a capital T, okay? And then we'll put whatever's happening to each of the coordinates. So if you're going to add 3 and subtract 2 to the y, it'll look something like that. Okay. So down here you can see that in this situation we're adding a to the x coordinate and then b to the y coordinate. So when you translate, you're going to move some direction left or right, and that would be your what you do the x coordinate. So this kind of signifies you're going in this direction. And then whatever you do to the y coordinate is telling you whether you're moving the shape up or down. So that's a translation. So once again, you're going to want to pause the video so you can determine Captain Hook is bearing a treasure, and you're going to start at the star, and you want to determine where the treasure is located following his 3 rules. So if you followed Captain Hook's rules, you should have seen that the first step was to go due south, which put you here, then you went west. Please note that west and south are also what we call negative directions. So if you see a negative sign, you're going to go left or down. And if you see a positive sign, you're going to go north or east. And so you should have ended up at the blue dot right here. And the vector is the line, the diagonal line, that's the shortest distance from point A to point B. So the vector would be this diagonal right here. We call that's our sliding vector. So if you look back to the cats, the picture of the cats, where was that? Here. You can see these are our vector lines. Okay? So let's go ahead and try some of these. This should be pretty familiar to you. So practice. One way that we write a rule, so there's several ways that we write a rule for translations. This would be one way. This is vector notation. So we're basically saying that this is what we do to x, and this is what we do to the y coordinate. Another way is we'll say x comma y. This is called arrow notation. Let me do it correctly. We'll say x comma y, and we'll put an arrow, and then we'll say like x minus 2, y minus 2. And then the third way is we'll put a big T, and we'll say -2, -2. So all of these things, all of these ways of indicating the rule tell you how to slide. And basically you're going to take your x coordinates and you're going to subtract 2. And you're going to take your y coordinates and you're also going to subtract 2. Like that. Okay? And you can also look on the graph. So for D, the point starts here. Again, this is a positive direction. This is a negative direction. This is a negative direction, and this is a positive direction. So I would go down 2, back 2. So this is where D is. I'm going to go down 2, back 2. This is my new point E. And down 2, back 2, this is my new point F. And so you can see that this is my new shape along the vector here. That's my vector. Okay. So if we look at example 2, this time we can see that this is vector notation when they put it in these 1, 4, that's called vector notation. I could also say that x, y is going to go to x plus 1, y plus 4. Okay, so right 1, up 4. Or I could say big T for translation, and then I put 1, 4. All of those say the same rule. So I'm basically going to take each coordinate, and I'm going to add 1 to the x, and I'm going to add 4 to the y. And I didn't do, well, I can do this one here. Plus 4, plus 4, plus 4, plus 4. Or you can just simply do it on the graph. So I'm going to go up 1, because up is a positive direction, over 4. Notice this, okay, 1, 2, 3, 4. So that's my new J. I'm going to go up 1 and over 4. 1, 2, 3. Oh, I got to kind of estimate this one. Up 1 over 4. It's K prime, and L is up 1 over 4. So that's where my shape currently is. And again, the vector that it followed would just take from the original to the new. So there's the vector. Okay, notice that they're using the rule here is t -4, 0. So that means x is going to subtract 4 and y is going to just stay exactly the same. So that's how we would write that notation. So go ahead and try this one and then come back and see if you did it correctly. My pre-image is in red. Pre-image. Okay, and then my image is in green, and so you should notice that it just moved to the left. It didn't move up or down because nothing happened to the y. All right, example 4. This time, again, they're writing it in T notation, so it's going to be x plus 1, y minus 3. Go ahead and try this one. Pause the video, try it, see if you get it right. I didn't graph this one, but what I did is went ahead and just changed the coordinates, so you should check your coordinates to make sure that they match mine. And I noticed there was a little mistake here that A should have been a T. I apologize. So these are the coordinates for the new figure. Remember, you added 1, so you moved to the right 1, and then down 3 with each of the coordinates. All right, now we're getting into homework, so make sure you can do these problems. Again, notice that these are written in vector notation. So another way you could write this is a big T with a 0, 5. So whatever the first is what you do to your x, that's what you do to your y. You could also write it as x plus 0, y plus 5. This one over here you could also write as t 1, 0, or x plus 1, y plus 0. Down here, big T 2, 3, -2, 3. You'll see that written sometimes. Or you could say x minus 2, y plus 3. And then lastly, these coordinates are x plus 2, y plus 5. Or you can write it in this notation where you say t 2, 5. T stands for translation, so it's going to be a slide. So this is part of your homework. In addition to this, you will also finish the packet and then work on IXL L2 and L4. And that's more practice on translations. Those are due Friday. This is due Friday. And this is due tomorrow. All right, good luck, guys. Let me know if you have any questions.